Hello, this is David Edwards with Team 3 from CS576. I am here to present our project for the semester. We've coined our project Leverage. It is a financial data application all running on Amazon Web Services, and we've set up these Jupyter notebooks, which it's a web server that runs on the remote machine, and then I'm port forwarding to my local one to allow me to access the directory structure within that. And what these notebooks do is give us the ability to have actual editable files. So if I went to any text file, this is all syntax highlighted and completely editable. In addition to that, we can run notebooks. And what a notebook is basically a command line terminal just wrapped in a web browser. And this first one is already running, and it's been running for a long time, and each cell is executable Python. So if I wanted to say hi, print hi, easy as that. And this one's already connected to a brokerage that receives market data, and so we can ask it if it's still connected. It says true, and then this is just defining some of the assets that are being tracked, and then requesting market data, a bunch of errors that actually are just saying that the connection is fine. And for fun, since this is a networks class, I made a little option network to represent options traded on the S&P as a network. And these notebooks allow you to do all sorts of manipulate data however you want. It's basically a command line terminal that allows you to do plotting. So this is the S&P over the last couple days. This is the variance futures on the S&P over the last few days. These are the, you can do correlations of the futures with the S&P. And then also do things like running ordinary least squares regressions in order to price things, and plot the residuals of that. And so this represents like a more stationary time series that is more predictable than something that looks like this, for instance. And you can do other things like this is moving averages, a rainbow of them overlaid over the S&P. And the other cool thing is this is talking to a database. If I open up another one of these notebooks, I can do the same thing, give it a different client ID, and connect to the same process. And each one of these notebooks will allow you to basically get real-time data as it's coming in. It will be updating the values within here. So the last bid on this asset was $18.15. And you can also do things like running backtest, which is like a simulation of a trading strategy. And the company I work for, we open sourced a project called Zipline, which does exactly that. So this is a basic implementation of that. I think it's just buying something every minute just for the sake of example, and then it'll give you a performance output of your every minute, and then the period open, period started, things like the capital used, ending cash value, it'll track the orders that you placed throughout that time period, and you can plot the portfolio value that comes from that. So what this would allow you to do is basically vet your ideas before putting any money behind them. And the real beauty of it is that you can trick the backtester into thinking it's a backtest and feed it live data. And then you're backtesting. If you're satisfied with how it performs in a backtest, you can fairly trivially actually trade it in real markets. By anytime it places an order, you would just pipe the order information from that order back to this original client that is talking to the brokerage, and it can place the orders on your behalf. And the primary part that we did for this project was adding this Jupyter Notebook interface, and it has ended up being extremely useful. I already had most of the financial workings going on already, but this we added the ability to interact with it remotely and also connect several clients, potentially run n algorithms against an account. Uh, and it's been extremely useful, fun to play with, and a great way to explore. I hope you enjoyed the presentation.